This worksheet, writing linear equations from a graph and table. So day 1 of Unit 3, that's great. You and your friends go to the state fair. It costs $6 to get into the fair and $2 each time you go on a ride. Consider the relationship between number of rides and total cost. Below are the table, graph, and equation to model this linear relationship. That's great. We can see from the table that if you have 0 rides, bam, you get $6 in cost, and then they're charging you for each ride after that. But also the graph shows the same thing. Once again, 0 rides is $6, 1 ride, $8, and so forth. The scale on this thing is important because each line is representing $2 for the y-axis instead of $1. That was extremely convenient, which we will see why in a moment. But they've also labeled these, which is important to remember. The labels on a graph will tell you a lot about the values that we find, which we will find here in a moment. The equation y equals 2x plus 6 is very nice. However, it's missing 2 very important things, and that is the description of x and y. We should have some kind of way to tell what the x and y is, just with the equation by itself and not the table or the graph. So we would need to do that, at least if we wanted a 3 or 4 on the test. So what is the sloppage of the graph? Where do you see the slop in the equation? We'll get to that, and then how is it represented in the context. Let's figure out what the sloppage is first. Alright, so we just need to identify 2 points on the graph that we can use to find good old sloppage. I'm going to use this point right here. And then to make my triangle big enough and visual enough, I will use this point right here. So let's go ahead and figure out what these are. I got a 0, 6, and then up in here I got 4, 14. Okay. So when I figure out my sloppage on these, I can make my right triangle like these. So I'm going to go up 4, sorry, not 4, but 8, thank you. And then I would go to the right 4, that's better. So I went up 8 and then to the right 4. I can simplify this fraction to be 2. If you want, you can make it 2 over 1. So that's how we would find the sloppage on the graph, which is very nice. But it also says to identify or tell what the sloppage means in context, which, as we can see, the upwards is the total cost. So when we went up 8, we were talking about $8. So the 2 would be $2 as well. Okay. And then we went to the right 4. So that's this 4 right here. 4 we can see from the x-axis because the label, which is why it's important to have our x and y-axis labeled. 4 is represented by rides. So that would be 1 ride right here. So in other words, the sloppage is $2 per 1 ride in context. Alright, the equation. How do we find the sloppage in the equation? Well, this is in the form y equals mx plus a b, which we went over in the last unit. And right here we can see that the sloppage has been replaced with this 2 in the equation. So let's go ahead and put a 2 in here. Right there. What about finding the slop in the table? Does anyone, you guys feel like you could do that? You should, because we did it in the last unit as well. So, remember this, all we must do is choose 2 points on the table, or in the table. Which 2 points do you guys want to use?
0.6 and 414.
0, 6 and 414, okay. Well, those are the ones we used in the graph, but it should show in here too.
So we already know our answer.
Alright, so the y, what's the change in the y's? From 6 to 14, you would add 8. Bam. So right there already your sloppage has a numerator of 8. And then from 0 to 4 would be an addition of 4. And that's the denominator. 8 divided by 4 is 2. So being able to find the sloppage in the table is also extremely crucial for this unit. All right, then at the bottom here it says, what is the y-intercept of the graph? Where do you see the y-intercept in the equation? What does the y-intercept represent in this context? That's a good question. So let's look at the graph, and then we'll look at the equation. The y-intercept is where the line that is graphed crosses the y-axis. So in this one, right here, we can see that that occurs right here, because this is our y-axis, this line right here, right? So if that is our y-axis, and that is where the line crosses the y-axis, well, we already identified the y-intercept then, okay? Which is pretty nifty, because it's not always going to be that simple, but for now it will. Well, yeah, so this is the equation part where we have b. B is the y-intercept, and we can see right here that the b is in the same position in the equation as the 6 is, so the y-intercept, and this is where we have to be careful, you guys, because on a test, it's going to say, what is the y-intercept? And here's what some of you will put, 6. That is false. It is not 6.
In the parentheses, it's 6/0.
That is close.
It's
0.
Yeah.
0, comma.
0, comma 6 in the parentheses.
Am I smart?
Yes. Well, as it turns out, for all y-intercepts, the x value will be 0. Always. Always be 0. And so as long as the equation is in slope-intercept form, then we should be able to find the slope and the y-intercept. Which seems kind of ironic because the name of the form of the equation is slope-intercept form. So hopefully that makes sense that you'd be able to find the slope and the y-intercept. And of course, you guys forget that. There's a poster right above the TV that you guys can look at for your viewing pleasure. All right. There is another part of that question, though, is it asked us to interpret the meaning of the y-intercept in this context. Well, remember the x represents the number of rides, so that would be 0 rides. And then the y is represented by dollars. 0 rides is $6. But in actuality, the context of the problem, we can see right up there at the top, it costs $6 to get into the fair. So before you take any rides, they're going to charge you $6 to get in. Bam. So,
My sister told me all this stuff.
by looking at the problems done in the previous chapter, you can see that one way to represent a linear equation is in slope-intercept form. In the previous chapter, you also derived the equation y equals mx plus b. So there it is. You don't have to memorize that stuff, by the way. Slope-intercept form of a linear equation is y equals mx plus a b, where m represents good old sloppage, and b represents the y-intercept, or initial value or starting point. That's pretty important to know, that initial value starting point garbage. If you're given a representation of a linear relationship, you can write the equation for the relationship in slope-intercept form by finding the sloppage and the y-intercept, and then replacing those values in the equation with the values that you found. That's what makes this so incredibly convenient. Write the equation of each line in slope-intercept form. Well, if that's the case, then we know that each of these should have some kind of y equals something in front of the x. And we can do that for all of these. And all I'm doing is replacing the sloppage into the coefficient of x, and then the y-intercept will be added or subtracted to the number of x's that we have. So, if my sloppage is 3, then it's the coefficient of x. Bam, there it is, right? Because the form is a y equals m, which is sloppage, times the x, and then we're going to add the b, right? That's pretty nice. Well, here's what we can see on a test. No, this is very bad, because you've given us a point to add to what kind of technically is already another point. So, even though that is the Y-intercept, we're only looking for the Y value, so just get rid of the rest of this garbage right here. That's a plus 4. So, I'll just move it over actually. Bam, 4. Y equals 3x plus 4. Alright, so Alright, so in this next one we got a sloppage of -2. And then the Y-intercept is 0. We're just looking at this 0 specifically. But here's the thing is, if you wanted to just write this as a Y equals a -2x, you'd be fine using the identity property of addition to simplify these.
That's the identity?
Alright, number 3. Can someone tell me the equation for these? Yeah,
Y equals 1/2 x minus 2.
that is correct. So sloppage is 1/2, Y-intercept -2.
Oh,
0,
I want to do
-2.
the next one.
Alright, tell me what it is.
Y equals -4/3. X. -1.
Well, -1. Yeah,
but
good.
same thing.
Yeah, okay.
What is?
Y equals -4/3 x minus 1. What about number 5?
Oh, just call him me.
Sure, one of you two.
Wait.
Oh,
Yeah, sure.
okay. Y equals 0x plus 4.
Bam. Plus 2. Now, this is okay with me. Some teachers get a little picky, though, and they may prefer you just to write Y equals 2, okay? Because, again, that identity property of adding 0 just means nothing. Me, I don't care, but I'm just warning you, in the future, other teachers may prefer that you write it like Y equals 2, just to say that it's fully simplified. I'm okay either way, though. Yeah, this is Slope-Intercept Form.
Oh, really? Oh.
Slope-Intercept. So what are the two things we need to write this equation?
Slope and the Y-intercept.
That's it. Slope and the Y-intercept, and you're good to go. Alright? Alright. Find the slope and Y-intercept from the graph, table, or story below. Then write the equation of each line in slope-intercept form. If you have a hard time determining where the line intersects a point, be sure to check at least 3 points. Fair enough. So here's number 6. Alright, if we can just identify the sloppage, then we'll have that part, right, in terms of our equation. Well, the sloppage right here, looks like I've got a few points I can use. I've got this point right here, which is at -9, -1. You don't have to use these two specific points, but you just need 2 points where you can find good old sloppage. And then I got this point right here. Looks like that is 7, 4. Well, I'm going to need my right triangle right here. So there's something like that. Right triangle. For this one, it looks like I would go up 5. So that's my numerator, up 5. And it looks like I'll go to the right, 9. Oh, that's a 6, by the way. Sorry, counting's hard. So that's 15. Well, I can simplify this into 1/3, so that is my sloppage on the D's. And that's what I have so far. Next thing I need to do is identify my Y-intercept. I can see the line crosses the Y-axis at this point, which is at 0, 2. So it looks like it's Y equals 1/3 x plus a 2. Number 7. So again, we want to find good old sloppage. We want the Y-intercept as well. And then we also want the equation in this form, Y equals mx plus a b.
Wait.
Alright, let's find 2 points that we can use to find good old sloppage. I'm going to use this point right here, which is at -5, 8. And then I'll use, I don't know, this point, which is at 7, -4. Well, for this triangle, looks like I'm going to have this here and this. So I'm going to go down, what is that, 8, 12. And then I would go to the right, 12. That's nice.
Wait, what's the other point?
That is at 7, -4. So my sloppage is defined. We went down 12. And then to the right, 12. So this would give me a sloppage of -1.
It's how you know that it's always rise over.
Alright, so in my equation I can fill in my sloppage with a -1. Next thing I need to do is figure out where my y-intercept is. Some kind of 0 value for x. And that looks to be where y is 1, 2, 3. So the y-intercept is 0, 3. And then I just make that a plus of 3 right here.
Wait, sir, how do we find the y-intercept? Is it just where the line crosses?
So there's the whole page if you really want it, because it's so fun to look at and very pretty. Well, we're going to do these exactly the same way we did the others. We just need to figure out 2 points to use up in here. So I got these 2 points. You don't have to use those exact points, but I'm using them. So my rise, it appears that I'm going to go upwards by 10. So I went up 10, and then my run, 0. Well, this should be pretty easy to do, especially if you got a calculator. 10 divided by 0, it's undefined. It's not 0. No, it is not.
Oh yeah, it's vertical.
Yeah, the next question. No, it is not undefined in a way.
Because it's not even there. The y-intercept isn't even there.
Yeah, let me ask you guys this. Where does the line cross the y-axis?
No, it doesn't.
It never will. There is none.
So what? No.
I knew it.
None.
Well, no. Yes.
Alright, so we need to figure out the equation for this thing, which is pretty simple. Okay, the problem is that it's not going to take on this form y equals mx plus b. Okay, so we can't rely on this form because it's very different. There's no y-intercept and the slope is undefined. So we have to figure out how the heck this thing is going to work. Here we have in this line, we can see that the y's are changing, but the x, is it ever changing? Nope. So we could just write this as x equals something. What value is the x? Quan.
5.
1. Now this is a very unique scenario, but the problem is that math teachers like to put these types on tests, so just be aware that it is coming. Alright, this one is also, again, very unique. So again, I'm going to choose 2 points. I'm going to choose this one and then these. So when I'm looking for my sloppage on this, I should get a fraction. What's my rise? 0. And then my run, what I got there is 10. You may have gotten something different. And then 0 divided by 10 is 0. Then let me ask you this. Where does the line cross the y-axis? Yeah. That's at 0, -3. So the equation is y equals 0x minus 3. Now here's the thing is, and that's a good question, is if we wanted to rewrite this using that identity property garbage, we can just write y equals -3. I accept both of these. Good luck.
Do it on the board.
But we'll not need it.
Do it on the actual
Technology.
Okay.
Technology here.
Do you even have any markers?
I'm gonna choose this point right here. And right here. Nope. Right here. Right there, yes. So that's -2. Okay, minus that. 1, 2, 3, 4, 5, 6, 8. There, and then there's 1, So yeah, like that. Good. Oh. Then that's wait. Is there an undo button? There. 2 over 5. There. So it'd be there.
All right, excellent work.
My handwriting is nice.
Now we have to be careful though. If something on this on a test, you'd lose a point for this stuff right here. And the y-intercept is 0, -3. But the rest of it is really good, okay? So excellent work on that. The other points we could have used are this one and this one. And then this is the one that he used right here. So in other words, the points that we have right here are good. And he had them written up here at the top, right? -2, -8, and then 4, 7.
Okay.
Good luck.
Now we can do it. Okay. Hi guys. So I'm gonna choose this one and this one. And so the slope, so we're gonna draw like that. It's the back sign. There we go. Why is it doing that?
No, you can't run while you're sitting down.
Oh yeah. Well, I was just gonna draw a triangle anyway.
Left or right?
That is really straight.
Left or right?
Nope. Oh my gosh.
Yeah, it's wrong. Nope. That is the worst.
There we go. Okay. Shut up. Okay. Well, so the rise is 1. So the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the rise is 12. The run is 1, 2, 3, 4, 5, 6, which means that it's what does that equal? That equals 1/2. Right? Nope. Equals 2. There we. Yes, it does.
Oh wait, yeah.
I'm not stupid. Okay, and then that's the slope. So which means that y equals 2x. Oh, there's not enough room. Shut up. Oh, it won't erase. Okay, well, y equals 2x. Well, wait, no. We don't know if it's a plus or a minus. Well, where it goes through the thingy. Right there? Is that the right one? Or is it this one? Is it this one or that one?
I don't know what you're doing.
It's that one. It's that one. It's that one.
Wait, I just have a question. Is it the one? But it's the Y.
It's that one.
Yeah, that's what I was thinking. Okay. Well, this is.
Good luck.
Thanks. Okay. And then this one. So this goes up. So this is up 5, 6, 7, 8. So 8. Right? Plus 8? Yeah, because it's in the positive, right? Plus. That's not working.
Alright, nice work.
I did it right too. If she got it.
Yeah, good job.
Did I do it right?
No.
Dang it.
Alright. There was something very small that happened. Everything else was right though, so that's good. Something very small is that she said she went down 12, so that's a negative 12 right there. Which makes the sloppage a negative 2. So it should be y equals negative 2x plus 8. That's all. The next thing, so we did all the graphs up there. Now we got to look at these tables, because if you can't figure out the sloppage in the y-intercept on a table, then you may be in bad shape. Well, let's figure out good old sloppage on this. But remember, we only got to choose 2 points on this table in order to figure that out. So which 2 points do you guys want to use? That sounds great. 1, 6, and 2, 10.
Yes.
There we go. So our sloppage should be some kind of fraction. From 6 to 10, you would have to go up 4. That's our numerator. And then the denominator would be to the right, 2. So 4 over 2 is 2. And in the equation, we can fill in the sloppage with 2. Next thing we must do is figure out what the y-intercept is. For now, they're just going to give that to you in the form of where x is 0. And that's right here. So the y value is positive 4. And yes, the y-intercept would be 0, 4. Well, this one's going to work the same way. Let's choose 2 points at random. Bam, found them. -1, -1, and 0, -2, right? So, from -1 to -2, that will be our numerator. Looks like we're going to have to go down 1. That's our numerator again. And from -1 to 0, you'd have to go to the right 1. That's our denominator. This should simplify to -1. So again, in the equation, we can write this as the coefficient of x, which is the sloppage, -1. Next thing we need to do is figure out where the y-intercept is. Well, I found where x is 0 right here. So this is my ordered pair, 0, -2. And I got y equals -1x minus a 2. There it is. Good one.
Oopsie.
Did you see my video?
How do you draw on this thing? It's not working. Oh, I got it. Okay. Can't do a plus. It won't. What the heck? Got this. I don't know. Oh, I got it.
Good job.
Close.
Am I doing it?
Very nice. Excellent.
Is this how it's done?
So on these ones, we got to figure out what the problem is with the equations that were written. All right, so the graph is just the graph, but what the heck happened with that stinging equation? Yeah. Yeah.
It's supposed to be like a negative slope.
Yeah, it's at least a negative sloppage because we know that because it's going downwards from left to right. Should it be -3 then? Well, let's find out.
No, it should be -4.
Well, I got this point right account and this one. It goes down 3 to the right one. So yeah, it's just that they forgot to make that a -3 sloppage. The rest of it would be the same. Y equals -3x. And then the y-intercept is still 0, 2. So that was it. It was just that they had a negative sloppage. Or they wrote a positive sloppage when it was negative. Alright, so what happened on this one? Right away I can see that they at least got the y-intercept right. Because the y-intercept is 0, -1. That's good. The problem with this appears to be with good old sloppage. We can see between these points right here that we would have went up 3 and then to the right 6. So that would be 3/6, which would make that 1/2. So it looks like they reciprocated the 2, the 1/2 into a 2 rather, but it should just be 1/2. Okay. So the actual equation is y equals 1/2 x minus a 1. The sloppage was all wrong. They did run over rise when it should be rise over run. Yeah, remember, these are things you should not do if you wanted to, get a 3 or 4 on the test. Tanner will explain what the heck happened with this equation. Good luck.
It's the y-intercept, because it should be, because it goes down 1, 2, and 3, and up here it is a +4, and it's also going down. So it should be negative. It should be y equals 3/4 x. No, where's the eraser? Is it right there? And then just okay. Minus 3.
Bam. Excellent. So does anyone know where they got the +4 from?
It's the x-axis.
Excellent. Yep. They got the x-intercept mixed up with the y-intercept.
You know why?
Just keep in mind that that happens often because it's just slope-intercept form. It's not slope y-intercept form. Okay. All right. This one is extremely different. Something very horrible happened on this one. They got y equals x plus 2, which is terribly wrong. But it's something that happens a lot, okay? This is a very common mistake that we see. For example, we got a y-intercept right here, which is at 0, 1. And the sloppage is up 2 to the right 1. So we got a sloppage of 2. So what happened here is that they have it as y equals bx and then plus the m. That's completely backwards, right? Yeah. It's not what we want to do. So they just switched the slope and the y-intercept around. So fixing this one, you'd have y equals 2x plus 1. You and your friends go to the state fair. It costs $6 to get into the fair and $2 each time you go on a ride. Consider the relationship between number of rides and total cost. Below are the table, graph, and equation that model this linear relationship. That was extremely generous of them. So we can see in the table that tells us based on the number of rides, right here, what the cost will be up in here. Same with the graph, of course, number of rides, total costs. And on this one, they should have indicated what the y and the x represent, which you will have to do, as we are writing linear equations from a graph and a table. Well, discuss the following. Highlight your answers on the table, graph, and equation above. What is the sloppage of the graph? Well, to find the sloppage of a graph, hopefully you guys remember these. But we can make kind of a stair stepper on these. We just got to identify where a couple of the points are. For example, we got a these, and then a these, right here. You guys remember the stair step thingy? Like this? Yeah, okay, good. Well, from 6 to 8, we went up 2 and then to the right 3. So that give us a sloppage of up 2 and to the right 3. Look, I don't know why I said 3. Yes, 1, thank you, that's much better. 1. I mean, we could simplify this to be just a 2 if we wanted to, but it doesn't matter. So keep it as 2 over 1 or 2. Now, based on what we did on the test, you should understand already that then for this one, I'm going to make it 2 over 1 so we can indicate what each of these represents. 2 was the rise, and the rise is represented by the cost. So it would be $2 to 1, which is the change in the x's up in here. That was the number of rides. $2 per ride. And this would be our sloppage on this graph and equation and the table. Be careful though, because here's one thing that we see often, which causes people to go astray, is we got this point up in here. That one is 1/8. So people say immediately that one ride cost $8. Well, it's $8 total, but you didn't pay $8 for the ride. You paid $8 after you took the ride and entered into the festivities. Alright, on this it is asking what the y-intercept is of this graph. I don't remember us talking specifically about y-intercepts in this class, but
We did.
I think I'm getting my stuff mixed up from my other classes. So the y-intercept is when the line, or where the line crosses or touches, some people prefer, the y-axis. So for example, if we had our y-axis right here, and our x-axis up in here, and this was our line for these. Well, this line is crossing the y-axis right here. That is the y-intercept. The y-intercept. Well, the y-intercept always has a value that we know, specifically for the x value, which is a 0. The x will always be 0. The y value will change, because I could take this line right here. Let's see if I can do that. Nope. And I could move it down up in here, like these. Well, if that were the case, now we can see that the x value stays the same, but the y value has moved downwards. So now that we know that, let's take a closer look at this graph right up in here. And I have already marked the y-intercept right here. But when it asks for the y-intercept, so let's label this the y-intercept, like these. The y-intercept, again, we know the x value is 0. But what is the y value right here? 6. Bam. There it is. Now we should be able to interpret what the y-intercept is as well. And this is part of the worksheet. The y-intercept on these, does anyone know what it represents? Well, here's the nice thing, is that the labels for the axes, and this is why it's crucial to be able to label and to know what they mean, is the labels for the axes tell us what each of these mean, right? So the x is the number of rides, so that'd be 0 rides. and the y is represented by cost. 0 rides is going to cost $6. Why is that? Well, we can go back to the word problem. That's correct. It says right here, it costs $6 to get into the fair. Another part of that question was, how can we tell where that is in the table? Well, right there we see that it's 0 rides. Where does we see 0 rides in the table? In this corresponding values. We got 0 rides for $6. Bam. What about the equation? Where is it in the equation? This plus 6 right here. Okay. Where do we see the slope in the equation, by the way? You guys need to know this. It was from the last unit. The sloppage is the coefficient of x, which is shown right here. That's the sloppage. This one gave us slope-intercept form. That was extremely convenient. Y equals mx plus a b up in here. Well, as long as we have these two things, the sloppage and the y-intercept, it is very easy to write the equations for lines. Because in the slope-intercept form, we got y equals m, which is the sloppage, times x. And then, of course, we add the b value, which is the y value there, okay? So even though they gave us the equation, we could tell pretty quickly that on this one, the sloppage, it were 2, or 2 over 1 if you really want it to be. And then the y-intercept was 6, so we replaced the b with 6, which kind of looks like a lowercase b anyways. So, again, this is very important for you guys to understand. If you have the sloppage and the y-intercept, writing the equation is extremely easy. And if you forget y equals mx plus b, the poster right above the TV will help you guys out. By looking at the problems done in the previous chapter, you can see that one way to represent a linear equation is in slope-intercept form. In the previous chapter, you also derived the equation y equals mx plus a b. That is slope-intercept form. Bam.
Do we need to know that?
You do need to know this. Yes.
Wait, is it gonna be like the nested where?
Yes.
Okay.
Yep. Well, if you are given a representation of a linear relationship, you can write the equation for the relationship in slope-intercept form by finding the sloppage, m, and the y-intercept, b, and substituting those values into the slope-intercept form of a linear equation, which is shown above. That's why it's so convenient, this y equals mx plus b. You need two things, sloppage and the intercept. Done. Specifically the y-intercept. I should clarify, all right? If it's a word problem, you also need to define your x and your y. So in addition to writing the form y equals mx plus b, like in that last problem, the x was the number of rides. So you'd want to indicate that x is number of rides, and the y was costs. But this is usually only for word problems. So let's do these 5, right? The equation of each line in slope-intercept form, which would be y equals mx plus a b. Well, for each of these, we can put a y equals x, and then I'm just going to leave the rest of it blank. We can do it for all of them. See that? Then we'll just fill in the blanks. So my sloppage, I'll try to keep this consistent. We can see on this first one, the sloppage of the line is 3. That's the coefficient of x. Bam, right there. And then my y-intercept is 0, 4. Now I don't want the 0 in there. Okay, we always know that the y-intercept has an x value that is 0. All I want is the 4. That is the b value, and specifically, this one is a positive 4. If that were a negative 4, we would put minus 4. Because that is a term, which is a 7th grade thing. But
Wait, how did you get that again?
These ones are extremely convenient because they're giving us a specific y-intercept. Now later on that won't happen, and that's okay. We have other ways to do it. But for now, that's really all that we need, okay? Because we're just kind of getting the hang of this thing. All right, well, this next one, right here, we've got a sloppage of -2, so that's my coefficient of x. And then my y-intercept, I'm just looking for the y value, which is 0 radical. Now, if you want to put plus 0, I'm okay with that. However, this is the additive identity, which means we don't really need the 0 there. But again, if you want to put it, I'm okay with it. It's the same thing. Understand, though, that other teachers may be really picky about that stuff. So they may not allow you to put plus 0, but I'm okay with that. Okay. On this next one, here I've got my sloppage of 1/2. That's my coefficient of x.
You skipped one.
And then I got my y-intercept, which is -2. So again, that becomes a -2 up in count. That's it. Well, what if the sloppage is -4/3? Again, that's my coefficient of x, no problem. And then my y-intercept, sorry, this one didn't fit, -1, bam. So I put -1 as the -1. There it is. Slope-Intercept Form of these lines. Let's look at number 5. Right here, we got a sloppage of 0. So that's my coefficient of x. And then we got a y-intercept that is a +2, 0, +2. Now again, I'm okay with this. This does indicate a sloppage of 0. However, again, some teachers may be really picky with this and say, well, that cancels itself out, so it's just y = 2. Either of these are okay with me. Alright. Alright, find the sloppage in y-intercept from the graph table or story below. Then write the equation of each line in slope-intercept form. If you have a hard time determining where the line intersects a point, be sure to check at least 3 points. Okay. Well, 6. We got a few points that we can look at up in here. In fact, we got a lot of points, and that's good. Look at these. Well, you can make a stair step. Let's take a closer look up in here. So you can choose any 2 points, but I'm going to use these 2 points right here. And we can see that between these 2 points, I went up 1, and then I went to the right 3. That gives me a sloppage of 1/3. The other thing they wanted, right, was the y-intercept, which is this point right here. And we can see the x is 0 here. I'm sorry, the y. Then we go up 1, 2. So this point has, and this is the y-intercept, by the way. This has a y-intercept of 0, 2. Very crucial information. Alright, so the sloppage we'll write in is 1/3. The b, this is one of the problems we see on tests, alright, is the b is 2. No, if we wanted the b all by itself like it's asking here, we need to show it as an ordered pair 0, 2, like these. The equation, though, we will just want the 2, and that's good. So I've got my y equals blank x, and then a blank. So then I got my sloppage, which was a 1/3, and my y-intercept is a +2, 0, +2. That is the equation. So we can see, as long as we can find the sloppage, and as long as the y-intercept is a highly, extremely convenient point to find, then this is pretty good. Number 7 has a lot of points to use, but among them, we only need to use 2, right? So I'm just going to choose 2 arbitrary, extremely random points like these. Well, from here, I can make my right triangle, which we love. And from there, we can see from this point, because I always go to the right, I'm going to go downwards, which is in the negative direction. How far down are we going to go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I went down 10. So right now, my sloppage is down 10. We'll see if we can simplify this, and we should. And then from right here, I'm going to go to the right, which is in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have -10 over 10, which turns out is just a -1. Bam, there's my sloppage. Well, what about my y-intercept? Well, I just need to look at my y-axis, and we can see the line is crossing the y-axis right here. Just what is that point? Well, again, the x value is 0, but what's the y value? 0, 1, 2, 3. Bam, it's 0, 3. So we'll write that in down here. And then what's the equation? It should be y equals something x. That something is the sloppage, which is -1. Some of you guys don't want to show the 1 right there, so you may erase it like these. But having it there is okay as well. And then our y-intercept is 0, 3, so that's a positive 3 up at here. There it is, our equation.
It's hard to write on this, so what happened?
There, okay. Sometimes it's...
Very hard to write with this.
Sorry. Yeah, if you put your hand on it, then it'll... So this line is extremely different than what you're used to seeing. However, they did give us, what is that, like 21 points right there to use, which is extremely generous. But we only need 2 of them, so let's choose. I will choose 2 that are far enough away for us to see right here. I got this point, which is 1, -5. Now, I didn't show that negative there just because of the way it printed. And then this one is 0, +5. Well, to find my sloppage, I only need to find my rise and my run. Well, I like to go upwards, up in here. And right there, I went in the upwards direction 10. So my sloppage right now is up 10. And what was my run? 0. It has no run. And what's 10 divided by 0? This one's great. This one's so awesome to do because it's 10 divided by 0. Well, how many times does 0 go into 1? Infinite. So this one is considered undefined. Like this. Okay? This is the state that I'm in right now. That was a 1, 5. Thank you. That's much better. Can anyone tell me where this one crosses the y-axis?
Nowhere.
It never will. There is none.
But it's so close.
So what does this mean for the equation? Well, we can write the equation for this. All right. The problem is it can't be in slope-intercept form because there's no slope or an undefined slope and there's no y-intercept. So for this one, and this is true for all vertical lines, it's going to be x equals something. Does anyone know what x equals? In this case, where did the line cross the x-axis? 1. You see how for all those points that it graphed for us, the x value is 1. So, x is 1. That would be the equation. Now this is a very unique scenario, and this is the only case where it's not y equals something. For all other lines, straight lines, we need y equals something, but in this case, there is no y. The y is not changing depending on x. Y is changing, but x is not. So x is 1. All right, what about number 9er? So again, we need 2 points to use. I got this one. Let's see if I can do this one right. I got -7 and then -3. And then let's use this point. We'll just use its opposite. That is at 7, -3. Well, for this one, for sloppage, which should be a fraction, what's my rise on this? 0. It didn't rise at all. What's my run? I got 14. And what's 0 divided by 14? 0. You can check that in the calculator, by the way. So my sloppage is 0. What's my y-intercept? We can see that this one does cross my y-axis at the point 0, -3. So my y-intercept is 0, -3, which sets me up for success on the equation y equals something x. Well, my sloppage is 0, and my y-intercept is -3. But again, you don't have to write it like that. If you prefer, you can write it as y equals -3. Either one of these will work. So it's kind of important for you guys to see the difference right there, right? And we already talked about how this gives us a horizontal line with a sloppage of 0. But a vertical line we just looked at, now it's x equals some value. Horizontal lines give us y equals some value. Good luck.
All right. So the y-intercept is right here, and it goes up, and it does that thing, you know. So to get up, to find the sloppage, we're gonna go up 1, 2, 3, 4, 5, and then go over 1, 2. So it's 5 over 2. I'm guessing. So wait, I don't know. Here, I'm gonna give it back to you because I have no idea.
All right, well, you're so close, and you didn't guess, actually. You did that in a very calculated way. Yes, the sloppage, you guys see that? He went up 5 to the right 2, so rise of 5, run of 2. So this right account would be good old sloppage, right? And what is the y-intercept? He did point that out as well. This point right here, yep, 0, -3. So when I write the equation for this thing, I got y equals something x. What is the coefficient of x? 5/2. Yeah, 5/2, it's the sloppage. And then the y-intercept, -3. That's it. Excellent work on that. All right. Good luck.
Thank you. So, I'm going to start right here, go down this line to this point. So, I believe, yes, we're still looking for m and b. So, for m, it's the slope, and it is -8 across 4. So it would be -8/4, which simplifies into -2/1, and that simplifies into just -2. So m equals -2. Next, the y-intercept is right here at open parentheses. Yeah. Y-intercept is at open parentheses 0, 8, close parentheses. So that would mean b is equal to, b is equal to 0, 8, parentheses. So then the equation would be y is equal to -2x plus 8.
That is excellent. Great work on that. Let's box that in so we have that down there. So the tables work very, very, very differently, except they're also very similar. The thing about these tables is that we have already learned how to find the rate of change, which is the sloppage for these. So as long as we can do that. Does anyone see where it shows the y-intercept in the table? Yeah. Alright, so we can see the y-intercept. What's the x value at all y-intercepts? 0. So we can see that it would be this ordered pair, 0, 4. Just again, don't you gotta fight the urge to just write a forward right account because it still is 0, 4, okay? Now in the equation, of course, that would become a plus 4, and that's good, right? Should be y equals something x plus 4. Well, let's find the sloppage. To do that, we only need to find or consider 2 points, right? Which two do you guys want to use?
The next one.
2, 8, and 1, 6. Okay, that works.
Yeah, that's great.
It'll work, right? Well, from 6 to 8, you would have to add 2. That right there is the numerator, because that's the change in y, the rise. And then the run right account, looks like we're going to go to the right one. 2 over 1, which we could just write as 2 if we wanted. And then we got y equals 2x plus 4. Good luck.
Let's see. So, 0 is right here. So this would be the y-intercept. So b. Oh, I moved it. Wait. So then. And -2. And then m would be our slope. I'll do these 2 points. So this would be -1. And this would be +1. So it would be -1 over 1, which would just be -1. Oh, how do we? No. How do we scroll down?
Gotcha.
So the equation would be y equals -1 x plus, no, sorry, -2.
Bam. That's excellent. Very good. Just clean up this part. That's better. All right. Good luck. Sarah, would you mind explaining why you do it, please?
Oh, yeah. So this one has the 0, so that's the y-axis. And then going from 1 to 2, you add 1. And then from 2 to 4, you add 2. So it'll be 1 over 2. And then y equals 1/2 x plus 0.
Bam. Excellent work. Well, it appears that we have an incorrect equation for these 4, and we got to figure out what the heck happened on these, okay? So on this one, here's the incorrect equation there at the top. Y equals 3x plus 2. Now, there's only 2 things that could be wrong on this, right? Either the sloppage or the y-intercept. Maybe both. You never know. Okay, but we should be able to identify what is wrong with these. Well, if we were to find the sloppage on this thing, what would it be? Yeah, this one, if we look at this point right here, and then this one, we can see we would go down 3, and then to the right 1. That makes our sloppage negative 3 times x. Now what about the y-intercept? How did they do on that one? Man, that one's good. Yep, that's a positive 2. So the only problem with this is that they forgot to make the sloppage negative. That's not too bad. Same idea on this one. What's going on here? Well, let's look at what the equation should be, and that should maybe help us out. So let's find the sloppage first. So I'm going to use, let's say, this point right here, and I will use this point right here. Doesn't matter which two you use, though, right? So if I make my stair step, that's much better. Right, from this point upwards, I'm going to go up 1, 2, 3, 4, 5, 6, 7. So my sloppage right now is up 7, and then to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my sloppage is 7 over 14, which simplifies to 1/2. So I got y equals 1/2 x so far. Now all I need to do is identify my y-intercept, which is at 0, -1. So that'd be -1. So what went wrong with the incorrect equation there? Yeah?
Did they put the run over the rise?
That's correct. Yep. They've got run over rise, but in fact it should be rise over run. Okay. So they've inverted, they've reciprocated the fraction, which is no good. So let's look at this one. Can someone tell us what the heck is going on up in here? There's something very specific that has happened, right?
Where?
Yeah, what do you got, Hannah?
It's not positive 4, it's negative 3.
Yes, so the y-intercept is incorrect, right? So, yeah, it should be, did they get the sloppage right, though?
Yes.
Yeah, the sloppage is correct. We should get y equals 3/4 x. Very good, -3. So where did they get +4 from? Gavin?
Did they go to the right instead of?
They did the x.
That's
Yeah.
what I did on
Whatever
the
that is.
first one.
Yeah, they did the x-intercept, not the y-intercept. So it's important to know the difference between these. The y-intercept is 0, -3. Okay. All right, what about number 18?
They mixed up the y-intercept with the rise, with the slope.
Yeah, okay. So this one, they have written the equation in the form y equals bx plus m. No, that's very bad. So we just need to switch those for them. Y equals what? The sloppage? 2x, and the y-intercept? Plus 1. Yeah, if you guys didn't see that there's that phantom 1 in front of the x, the coefficient of x. Okay? So as long as you guys can do that, well, you'll be in pretty good shape. The problem is in the future, right? Let's look. So this lesson is pretty easy because they gave you points like 0, 4, and then maybe another point like I don't know, 2, 5, right? Something like this. The problem is in the future, instead of giving you the y-intercept like at these, they may give you something like at these. Okay? Now, what's the problem with this? Well, we don't know the y-intercept, but can you guys find the sloppage from 2 points?
Yes.
Should be able to. Whether you guys use rainbow method or the equation stuff, doesn't matter. As long as you can find the sloppage, you should be able to write the equation. Just not yet, okay? We'll go over that next time, sometime.